So at this point, you're probably wondering, okay, we've seen one way to create a user-defined type. That was a struct. Why do we need classes and how is a class different from a struct? Well, we'll go ahead and look at that now. What we're going to see here is the primary difference is going to come down to the visibility of the data members. A struct is going to be essentially allow us to define a type whose members are going to be public by default. When we're defining, say, types using either a struct or a class, from here on out, we're going to include essentially the access specifier within all of our definitions. So when we declare, say, a struct color, what we're really saying is that we're creating a new type, color, and all of its data members by default will be public. What this means is that if we write something such as color C1, we can directly access the R data member from outside the class directly. Now, why might we not wish to allow this behavior? Why might we want to prevent direct access to our data members? Well, valid values for RG and B are essentially between the integer values 0 through 255 inclusive. So if we allow direct public access to each data member, you could have someone maliciously write or inadvertently write something like this. At this point, C1 is no longer following that it comprises or represents a valid color object. So the idea with classes is essentially they will allow us here, what we'll see shortly, is ensure that any sort of interaction with the data members is done so to maintain some sort of invariant, such as from the construction to the destruction of a color object, we're going to ensure that all values stored in the data members are valid color values, so within the range of 0 through 255 inclusive. We're able to do that using information hiding. So if we go ahead and look at our class definition, it looks very similar with the one difference that the struct keyword is replaced with class. And essentially what that means is that by default, each of our data members or anything declared within the scope of our class is going to be private and inaccessible from outside the class. So what this essentially communicates is that everything that falls within this definition of color will not be accessible from outside, from things that are scoped outside the class. So considering that class members are private default, what does that mean? Well, if we go ahead and define our color type to have 3 integer values, RG and B, and then we go ahead and attempt to create a color object, if we were to directly access, say, those members, what we'd observe when we go to compile our program is a compilation error, essentially communicating that those data members are private of color and that we're unable to interact with them directly from outside the class. So the next question begins, okay, well, how do we interact with them at all? What we'll see here is that moving forward, we're typically going to declare our classes as follows. We'll have some sort of public visibility header at the top. And we'll go ahead and define a number of functions which will comprise the interface to objects of this type. By interface, we essentially means what the user can use to interact with them. There will also be a private portion, which essentially the data members will be listed under, and that will hide them from direct access from users of our type. In addition to this, we will also include functions that help implement the different behaviors specified within the actual interface. And then as always, we'll go ahead and terminate our definition with the closing curly brace along with the semicolon. So we'll get into this here now when we begin talking about the structure of a class.